Historically, peatland has been removing carbon from the atmosphere. However, with drying climates and human activities such as animal grazing, scientists are looking to see if the peatland functions have flipped from being a carbon sink to being a carbon source. A Flux Tower is an advanced weather station that measures the transfer of carbon dioxide and water between the land and the atmosphere. This Flux Tower has been installed as part of the Improving Falkland Peatland project.
It contains all of the things you'd expect to have on a weather station, but it also has the additional capability to measure the flux, that is the exchange of mass and energy between the land surface and the atmosphere above it. It's a very advanced technique, so what this allows us to do is it allows us to measure over big distances. So although the instrumentation is here, the sensitivity of the instrument is several hundred metres upwind of itself. It allows us to measure how the whole ecosystem functions.
But how actually is the data gathered, and how does a Flux Tower work?
The part with the prongs there, that's called a sonic anemometer thermometer. This is a sensor that measures atmospheric turbulence.
This top part of the tower, with a tongue-twisting name, is used to measure wind coming from 3 directions. And this little white box is called gas analyzer, and it measures the concentration of carbon dioxide and water vapor. These 2 devices together are used to calculate the flux.
These 2 here, we have 2 upward and downward facing sensors. These measure something called the Normalised Difference Vegetation Index, or how green the ecosystem is, and it will allow us to see the seasonal change in vegetation. This is effectively the brain of the whole thing. So inside this box we have a data logger. So this device tells the sensors what to measure, and it receives the data from them, and then it logs it to a card similar to the sort of card you'd get to store data on your mobile phone. So as you can see, this is a screw. So we're going to make a hole in the ground, we'll screw this in, and then this measures soil temperature and moisture at different depths down this profile.
The Flux Tower is a huge step forward in collecting data for the project. However, there are other ways to measure the carbon transition between land and atmosphere. Falklands Conservation and SARI have received another piece of equipment called flux chambers, which will also be used for the project in the recent future.
Equipment we showed you last time, they were flux chambers, and this is a flux tower. It does very similar things, but in much higher resolution. It's recording all of the time, 24/7, 365 days a year. So it just gives us higher resolution data for the 4 points we've chosen around the islands, which then complements the 20 sites for the flux chambers.
Both Flux Tower and chambers are measuring the amount of carbon the peatland is accumulating now. But to see the whole picture, it is necessary to go underground and find out how much carbon was stored thousands of years ago. To do this, sediment scientists use an unusual-looking tool called a Russian corer. The device is pushed in a hole into the ground to a set level, and after it is twisted around an axis, it traps the soil sample within the chamber.
We're taking the cores in 50 centimetre increments, and we take overlapping cores down to the bottom of the peat, and this peatland will bottom out in grey clay. So that gives us the full record of peat and therefore carbon accumulation from the point at which this peatland was initiated.
We found the contact point between the clay that underlies this environment and the peat growing above it. So it's a really nice kind of change in the strata here. You often find these kind of clay layers, they effectively stop the water draining, and that kind of partly explains why the peat can start to build up. It's a much more waterlogged, wet environment.
And we know that the peatlands absorb carbon because here we are sat on a peatland which is made up of carbon that's trapped in plant material, and there's thousands of years of carbon stored like underneath my hand here right now. So there's 2 parts of the project. There's the Flux Tower, which is telling the researchers about the actual gas that's coming off the peat, and then the other side of the project is understanding exactly how much carbon has been stored in this peatland in the past. But we can look at how much peatland has accumulated every 100 or every 1,000 years, and that tells us overall what the carbon sequestration is, so the drawing down of carbon out of our atmosphere into our peatlands and locked away hopefully for eternity unless the peatlands erode. That is a major important way of getting carbon out of our atmosphere.
The joint project between Falklands Conservation, SARI, BAS and the UK Centre of Ecology and Hydrology has potential ecological and financial benefits for the islands in the future.
Can we actually start putting the carbon back into those systems? Because if they're in good nick, they can really capture carbon faster than almost anything else on the planet, actually. And if they can do that, are there opportunities to sort of attract investment from people to support that happening? There is a lot of money out there looking for places to invest in carbon, and that's maybe a new income stream for the islands that, you know, might help to improve the state of the ecosystem.
A flux tower like this doesn't come cheap and could set you back by roughly £50,000, as it contains expensive components including a high-quality solar panel. The installation of 4 flux towers in the islands has been split between FIG and DEFRA.
We've been setting these things up in the UK for the best part of 10-15 years now, I guess. I think we're up to about 50. Earlier, there's only 2 of these things on peat in Wales, for example, so Falklands is now beating Wales. It's about on the same level as Northern Ireland. There's more peat than there is in Wales or Northern Ireland, so it's a big resource the islands have got, and understanding what state it's in seems quite important, actually. So is the system still functioning like it used to? If it's not, why isn't it? Is it something to do with the land use? Is it something to do with the climate changing? And if you know that, you can then make, hopefully, better decisions about how to look after it.
2 flux towers have been installed on East Falklands, and 2 more are set to go up, one on Bleaker and one on Weddell. Although the joint project may be in its infancy, it has real potential to further develop the island's understanding of its local environment and carbon footprint. This knowledge may be a first step to improving our ecosystem and mitigating the negative effects of climate change.
It's been fantastic to come out and see the first carbon flux towers being installed. It's a project that government supported with Falklands Conservation, started, maybe 18 months or so ago. So actually to come and see it on the ground is really fantastic. Climate change is something we're all talking about, and understanding the drying of the land and all the implications are, very much on everyone's mind. So to actually get some equipment in here which is going to allow us to understand different environments and habitats, to understand what they're doing, I think is going to be really important for us in the future in all sorts of different ways. Now,
we're really interested in understanding what makes a high accumulation rate site, so what makes a really healthy peatland become a really good carbon sink, and how can we make sure they still operate well during the era since humans have been on the islands. We've got to look after these carbon sinks, not just the peatlands and the Falklands, but all around the planet, in order to make sure we're drawing that carbon out of our atmosphere.
Understanding carbon emission is a key step for understanding the effects of climate change. And as the data collection has just begun, the results of the 2-year research project may bring significant changes not only to the Falklands' future, but also worldwide.